Okay, so let's get started. We're going to be taking a look at working with spark timing and understanding conceptually what happens within the internal combustion engine with spark timing. This is more of a general overview of spark timing so that when we move into the next few tutorials working with spark timing in the Gen 3 control module, we'll understand conceptually what's going on and we can break down the more complex spark timing routine that things are called out and programmed here in our Gen 3 control modules. It's important to understand the concepts, the basics, before we move into a lot more complex topics talking about spark timing. So let's jump in here and let's take a look at a nice illustration to begin this tutorial that's going to run through what the actual 4 strokes of the engine cycle represent, where spark timing fits into the different strokes of the engine cycle, and then understanding what we're trying to accomplish with spark timing. So when we go in and command a certain amount of spark timing, we fire off our spark plug, what are we actually doing? We'll also then take a quick look at 2 different tables here in the Ford logic to just understand very basic overview of how the spark timing is going to work. And that should be wrapping up the video. So it's going to be a relatively short video, but it should hopefully allow you to understand what is going on here. If you have kind of a fuzzy idea of what spark timing represents, a lot of people may understand it's when you fire off the spark plug, but they may understand what we're actually trying to accomplish. Okay, let's take a look at our illustration here. This particular illustration is a generic inline 4 or 6-cylinder engine. So this is not going to be Coyote specific, but what we can take away from this tutorial can apply to any piston engine. So even though it's an inline 4-cylinder, the concept of spark timing here will be clearly represented. So looking here at our illustration, we first begin on our intake stroke. This is where we pull the fuel and air mixture into our cylinder, and we start to see that the piston is going to move from top dead center towards bottom dead center. This movement of the piston and rod assembly and the crankshaft starting to rotate, this creates a suction effect, pulling the air and fuel mixture in. Now, the Gen 3 engines are direct injection and port injection. So depending what mode we're operating in, whether we're spraying the fuel out of the port injectors or spraying the fuel only out of the direct injection, the fuel as it's coming into the intake stroke, may be coming straight into the combustion chamber with the direct injection, or it may be coming from upstream on the port injectors that are located in the intake manifold. So it really kind of depends on which mode the engine control module is operating in. In this particular illustration, this would be assuming it's port injection only. So we're drawing the fuel and air mixture in through the intake port as a traditional port injection engine. So looking at this, we'll get to the point where we reach bottom dead center on the piston's travel. Then the piston's going to start to change direction. It's going to move towards top dead center on this compression stroke. This is where we compress the fuel and air mixture, and then we fire it off with the spark event. When we fire off the spark plug, this is going to generate a explosion, a flame front, and once the piston reaches top dead center, it's going to start to push its way down towards bottom dead center on our power stroke. This is where we actually extract the horsepower and torque out of our engine from that combustion event, that explosion that happens. Once we reach bottom dead center on the piston travel, we start to move towards top dead center, so the piston changes direction. We're then on the exhaust stroke. That's where the exhaust valve opens, and it starts to discharge any of the burnt combustion products, or combustion that happens. So any fuel and air mixture that combusted, it's going to be pushing that out the exhaust valve, out the exhaust, and into the atmosphere. Then we start the cycle all over again. So again, we have our fuel and air mixture drawn in. The piston moves from top dead center to bottom dead center, and then we move into the compression stroke. And that's really what we want to focus on for this training module. What happens between the compression stroke and the power stroke? Now, in this particular example, if we're taking a look at when the spark plug's actually fired off, this is actually closer towards top dead center. This would be known as retarded timing or late spark timing. We find that if we command the spark timing to happen that late, we'll find that we usually lose power and torque output out of the engine. This is really done to offset any possibilities of knock or pre-ignition, which is essentially uncontrolled combustion. If we have poor gas in the tank or the combustion temperatures are very, very high, so what's drawn into the cylinder and what we have in the combustion chamber is really, really hot temperature that we can find the engine can knock or pre-ignite. That's where we could run into a situation where we have uncontrolled combustion, very uncontrolled cylinder pressures, and we could damage the piston rod assembly, the cylinder wall, the head gasket, it can lead to catastrophic engine failure. So we want to avoid that. And that's where we call out late spark timing, as we would find in this example. We're firing off the spark plug very late in the compression. Thanks for checking out our teaser clip. If you want to see the rest of this video and more than 500 hours of current EFI training we have to offer, make sure you click right here. If you want to go and check out more teaser clips from this training course, click here. And you don't want to miss any of the videos we're going to be releasing on this channel, so make sure you subscribe and click here. Thanks for watching, and I'll see you guys later.